Today we're going to learn all about the coordinate plane and how to graph rational numbers in the coordinate plane. So you're going to remember a few things. This first number is our x-coordinate, so go ahead and write that in your notes. And the second one is y. Okay, so a baby can always crawl, meaning they can go left or right before they can walk up and down. So always remember that. I know in chapter 8, many of you were forgetting which one goes first. So you go left or right first, meaning the x-axis, okay? And then up or down on the y-axis. So this coordinate plane shows point P, where my x, meaning they go left or right, is -1, -1/2, so -1 and 1/2, and going up and down, it's 3/4. This grid line represents -1 and 1/2, and y is equal to 3/4 because it is halfway between the grid lines for 1/2 and 1. So you always want to look at your grid and say, okay, well, how far apart are my lines? And here you can tell that there are two lines between any 0 and 1 or 0 and -1. So each graph or each line represents 1/2.
Use fractions or mixed numbers to write the ordered pair for each point on the grid. Identify the quadrant for each point.
So many of you will remember, if you want, go and freeze this and write which quadrant is quadrant 1, which is quadrant 2, which is quadrant 3, and which is quadrant 4. Again, freeze it, see if you're right. Quadrant 1 will be here, quadrant 2 is here, quadrant 3 is here, and quadrant 4 is here. They go counterclockwise. So they want us to use fractions or mixed numbers to write the ordered pair for each point on the grid. Identify the quadrant for each point.
You can use what you know about writing ordered pairs of integers to write ordered pairs of other rational numbers on the coordinate plane.
So I'm going to go ahead and I'm going to write, well, quadrant point A is over 1 and 1/2. So A is 1 and 1/2. Left or right, and then when I go up or down, I know that it'll be 1 and 1/2 up or down. So A is going to be at 1 and 1/2, 1 and 1/2. That is in quadrant 1. Quadrant 2, I know will have D in it. Okay, and the points for D, if I go left, is -3/4, because it's not quite at -1, but it looks like it's right in between -1/2 and -1. So no, that'll be -3/4. And going up, it's a little bit past 1, but not quite at 1 and 1/2. So it must be 1 and 1/4. Okay, point C is in quadrant 3. Okay, and that looks like we are crawling to the left to -2, because the baby can crawl before they can walk. And they're going to move down. Here's -1, -1 and 1/2. So right in between there is -1 and 1/4. Go ahead and try finding quadrant B. Sorry, not quadrant B, point B. It's in quadrant 4. Okay, go ahead and try solving that. Freeze your screen and see if you get it right. So quadrant B is in quadrant 4, and they get 1/2 because the baby can crawl to the right 1/2, and -3/4 is their answer for that.
What ordered pair names point B?
Okay, go ahead and solve this on your own. Okay, press pause. Solve this problem on your own, and when you're done, go ahead and move on to part 2 with me. I will be checking this in your notes for accuracy.
Plot each point on the coordinate plane. Identify the quadrant for each point.
So when you go ahead and get started with this one, I'm going to take a point. Well, point A will be at 1.54. So that means it can walk 1.5 over, so somewhere in between 1 and 2, so right here, and it goes up to 4. So I'm going to go ahead and I'm going to make a dot at 1.54. Okay, I know that'll be A, so go ahead and do that. That'll be in quadrant 1, so I'm going to draw a 1 right here. And right next to that, draw an A. Okay, B, negative 2 over negative 2.3. Well, we're going by 1, so here's negative 2, here's negative 3. 2.3, negative 2.3 would be somewhere in between negative 2 and negative 3, closer to negative 2, so I'm going to put B right here. Well, I know that is in quadrant 3, because this is quadrant 1, 2, 3. Okay, C is at negative 1.7. Again, that'll be somewhere in between negative 1 and negative 2. I'll say right here, because it's closer to negative 2. And then positive 1.5. So that must mean I'm right here. Okay, that is in quadrant 2. Okay, and I have point C right here. D is at 1, negative 0.7, or negative 7/10. So D will be in quadrant 4. Okay, go ahead and graph E. So they don't go left or right, so I know it'll be on the y-axis somewhere. E will be on my y-axis. Go ahead and try that, and when you're done, let's move on to the next Got It question.
Which point is located at 2 4/10, negative 7/10?
Okay, so remember, a baby can walk or crawl before they can walk. So that means they can go left or right before they can go up or down. Go ahead and graph this, find what point it's at, okay, and then I will move on to part 3 in your notes.
When two ordered pairs differ only by the signs of their coordinates, you know that they are related by reflections across the x-axis or y-axis, or both axes. A reflection across the x-axis changes the sign of the y-coordinate. The x-coordinate remains the same. 2/3, 1 1/3, reflected across the x-axis is 2/3, negative 1 1/3.
So remember, this first ordered pair, the number in the ordered pair is always the x, and the second is the y. So they're saying if you're reflecting across the x-axis, meaning this one right here, you are changing just the y. So it's going to be the same numbers, but they're just making this one a negative because they're flipping it over the x-axis. So what do you think, go ahead and predict, is going to happen when we reflect across the y-axis?
A reflection across the y-axis changes the sign of the x-coordinate. The y-coordinate remains the same. 2/3, 1 1/3, reflected across the y-axis is negative 2/3, 1 1/3.
So remember, since we're reflecting across the y, and if this first number is always my x and the second one is my y, I know that I am going to just change this first number. So they're the same, but they make this a negative.
A reflection across both the x and y axes changes the signs of the x and y coordinates. 2/3, 1 1/3, reflected across the x-axis and the y-axis is negative 2/3, negative 1 1/3.
Reflections are mirror images. Everything is the same but in the opposite direction. In a mirror image, your right hand becomes your left hand. When you turn left, your image turns right. Similarly, opposite x-coordinates reflect mirror images across the y-axis. The word opposite comes in handy when you're thinking about reflections.
So what I'm going to do and what I want you to do is on your notes, I want you to write x, comma, y. Your x-axis number always goes first, followed by your y. So if they want us to reflect across the x-axis, we're going to have the same numbers, but we're going to just change my y. So that means that my first number and the ordered pair will be negative 1/2. And my second number is going to be the opposite of this, which means it'll be negative 1/3. Okay, for this next problem, they want us to change my, or reflect across the y, so I'm just going to change my x. So that means if x is the first number, I need to do the opposite of this. Well, the opposite of negative 1/2 is going to be positive 1/2, and I keep the second number the same, so I'm looking for positive 1/2, 1/3. Now they want us to change both. So for this one, I know that if I have to change both, I have to do the opposite for both. Well, the opposite of negative 1/2 is positive 1/2, and the opposite of 1/3 is negative 1/3. So I'm looking for the ordered pair, 1/2, negative 1/3.
What is the reflection of the point negative 2 5/10, 2 75/100 across the x-axis?
So what I would like for you to do is go ahead and solve this problem, and when you're done, I want you to go back through the notes today and make sure that they're organized, they look nice, and that you triple check your work. A lot of the reasons why we didn't get as many points as we could on the 9-1 through 9-3 notes is because we rushed through it, we left a few things out, and we didn't check our work.